Okay, so why this presentation? First of all, in the eArchiving building block, we started developing the guidelines for preserving geospatial information systems. And in the short time we had, we learned a lot about it, and we want to present what we learned. We also want to ask you guys to give us some inputs, maybe questions, maybe suggestions. But to start talking on this level, we need to have the basic information first. So that's why I would like to discuss what kind of preservation strategies we could use and what elements are necessary for it. But first of all, what's the agenda? First, why we preserve a GIS and how is it different from a geospatial data? Because we already have been talking about the geospatial data in its formats and the metadata and so on, but why the GIS? What's different here? Then how and what we should preserve. We'll describe the GIS system, its basic elements, and then look from the preservation or for the archival perspective on how to approach this. And then last but not least is a chapter on, is your GIS ready to be preserved? What do we need to know about it? And what we can do now before we implement some guidelines or specifications. So why should we preserve a GIS, and how is it different from geospatial data? To actually cover this, we want to go to the definition of a GIS. So what is a geographic information system? So if we go to the basics, it's a system that helps us store, manage, and retrieve information about objects in space in form of geoinformation products. This is just one very basic definition. There are other definitions that you can find. But what you see on this image is an analog GIS. This is actually a system that stores maps. And based on this system, we can receive and retrieve information about geoinformation products, which can be a map of a territory, of a certain part of the territory. It could also be a length of a river or the height of a mountain or any type of information that we want about the space, about the geography, about the objects in the space that surrounds us. But now if we go to the digital domain, let's see how a digital geoinformation product is created. So this is probably a slide that you already saw sometimes, but it will give a good introduction into what we want to achieve with the preservation of GIS systems. So basically in the digital realm, we have input data, which is type of vector data, raster data, or databases. We also have some lists and code pages, information about the data. But to actually get the, let's say, the river length or the information product from it, or a map or a 3D object or whatever, the volume of a 3D object, because this is the information product we want to receive out of it. And this is something that an organization issues based on this data as an official record sometimes. Then we need a GIS tool, which is a system that actually helps us organize, query the data, align the data with other data so that they match, transform the data if needed, create new data maybe. We also use the tools in the GIS to render the data so that maybe not all rivers are the same width or color, or maybe not all roads, or maybe not all polygons or objects are not of the same color. We also have functionalities of exporting and geoprocessing data, analyzing structures inside it. And one of the types of geodata information product is a list. It can be a list based on maps, based on geodata. So you see that there's a discrepancy between the geodata and the information product that is derived from the geodata. And basically, what the archivists most commonly want to do is actually preserve the capability to actually create the information product. And this cannot simply be done by archiving geospatial data. So we need to have a logical step in between, a step on how to reconfigure, reuse the geodata to actually create and produce the information product. And then when we're done, then we have the information product in form of a map on the screen. So this is the basic idea. Okay, now let's see what also influences the creation of a digital information product. One thing is that we have different types of GIS systems that vary from simple ones that are standalone systems where a person has a GIS software installed on their computer. They store their maps in a file system that can be then stored as file objects. And then we have digital information products that are usually created in form of a paper map or a digital map in a PDF or something. And this is something that is rather simple. Now, in the development of GIS, maybe this person in an organization, maybe it was a county or a municipality, told about the GIS to other people, and they also wanted to use it. And they also had their own standalone systems. But as the organizations grow, they usually start creating enterprise environments in which they share the data that is stored on the same server in a different file format, in this case, maybe in a database, in an Oracle database, or today also in some open source databases. And this is where we start merging or changing different format types and different preservation approaches, because we know that we approach database preservation differently from, I don't know, ERMS representation. Now, this is still a closed system in which we have an organization with different departments, and now the enterprise systems also open up to the public. They can open up, and we can have internet access to the enterprise system with web clients and mobile clients. Maybe we have a person who is doing the maintenance on the roads, on the fire hydrants, on cutting the trees, on I don't know, commercial posters or whatever in the field, and this analyzing this through a mobile application, accessing the data and entering the data into the enterprise database system. So we see that this system now is a little bit more complicated in terms of what kind of geospatial information products are created and where the data comes from. So if we want to reproduce that information product, we need to know exactly how the data is organized in the enterprise and from which side the information comes. But this is still not the end. We now know that organizations connect with each other, and we can see that we have different organizations all connecting into a distributed GIS system, into cloud environments. We have government clouds that host different geospatial data from different organizations, ministries, agencies, and so on. And they might have different types of GIS systems with different database organizations, different types of databases. Maybe some have a hybrid of file systems and databases and so on. And that is what where we see that sometimes we might have a user that actually uses all those services. Let's take this user, for example. And this user works in a local office where they create information products that are called, let's say a building permit. And this building permit needs input from different databases to actually create this information product. But this organization doesn't really own any geospatial data. So we need to have this system organized and documented well enough so that we can then reproduce or re-access the data, retrace the steps if needed. Because if you go to this information product, as you have probably seen this slide before, the building permit might be created based on different databases from different organizations which have different strategies of preserving them, and maybe they cannot ensure that they can get the information from 5 years ago from the exact date, or maybe they don't have the same approach to dealing with this. So the retracement or tracking of these steps might be very difficult. So how should we approach this? How should and what should we preserve from a GIS system? I mean, it would be too complex and too costly to actually store all the databases and servers and have them all in the same place and work with them because the maintenance of all of it, the knowledge, it's too costly, and we have different approaches for that. So to actually answer this question, let's first start with the approach on how do we preserve digital objects. So basically, the fundamental challenge of digital preservation is actually to preserve the accessibility and authenticity of digital objects over time and domains and across changing technical environments, because this requires acceptance of both the inevitability of change and of the inherent separation of the logic information object from its physical environment. We will not store the hardware and the software probably. And of course, in the light of supporting the digital economy, if we want to present the data to make it available to the future users like the AI, the big data applications and so on, we want to have them in a simple machine readable form available in the standards that will be actual at the time of the access. So that's why we need to identify and the significant properties of GIS that in the archival domain can be specified as content, context, structure, rendering, and behavior of a digital object. And if we translate this to geospatial, to GIS terms, the content is the geodata. The database is the metadata actually provides the context. We also have the additional documentation sometimes necessary, or the source data that helps us to understand the context. And then we have a structure of how this data is organized and structured so that we can reproduce some information products or digital objects. Then we also need to render the data. As we said before, maybe we would like to have a river that is wider because it's more important than the other river, which is not a river, it's a stream. So that's how we differentiate using rendering. And of course, we want to save the behavior by having the access to the workflows, to the rendering algorithms, to the analysis functionality, etc., etc. Now, this is the cornerstone of our approach. And if we want to do this for GIS, we first need to know about the GIS components and how to store these components. For the people who are familiar with Geographical Information System, this is a very known slide, or let's say a concept. The basic elements of GIS are hardware, which are the computers, networks, and so on. Then we have the software, as every system needs to have the operating system, database system, and a GIS software to work on it. The data itself, which we know, which are the raster data, the vector data, the image and attribute data, the databases, the methods, which are well-designed plans and application-specific business rules that are describing how the technology is applied, and also some standards, specifications, procedures, and of course, people who actually have the knowledge to actually use these methods and data on the software. And how are we going to save this? Now, based on my knowledge, we usually do not store hardware. So this is out of the question. We definitely know that we store the data and we want to store the methods. So most common queries, specifications, documentations and standards and procedures and so on to help us recreate the information based on the data. But what about the software? Sometimes the logic of the method is actually described in a software, but one way to store the software is to create a virtual system that actually stores a simulation, or we can store some code that can be reinterpreted later on a different system. But this is still something that needs to be debated. And regarding people and the knowledge of people, we cannot store people. However, we can reference the body of knowledge about GIS, the body of knowledge that is needed to actually understand the methods and to understand the data and how it was created, what methods were used for its creation. Now, if we check, we actually have most of our 5 elements: the content, the context, the structure, the rendering, and the behavior available through storing data and methods. We could discuss about the storage of methods as software, as code, and how to reference the body of knowledge about GIS if something happens and we forget. So if we go back to the presentation of our creation of the digital information product, we can see that now we have new approaches on or new designations of certain elements of this GIS. First of all, we know that geodata is content. That's not disputed, and we knew that before. However, if we want to reproduce the digital information product, we also need to store the structure, so the organization of the data, the cartographic projections, the transformations, which could be argued that the transformations and projections are rendering. Then we have the rendering element about symbology, map layout, and the way that the information product looks in the end, how it is created, so it helps us to recreate it. And of course, the behavior of the system can be defined by definition of workflows, the use of analysis tools, which are defined in mathematics, and maybe some export elements. And there are standards for that. What is new is that we need some additional context, which gives us information about the data and about the information product. And this information product can be defined by GIS metadata. So we have metadata standards for defining web services that are derived from a lot of data and content from databases again. So this is one of the answers of how to store a GIS. Now, what is our approach on the definition of common technical specifications on the eArchiving building block? So far, what was available is the GeoSits specification 2.04. We just finished the first review of this specification, I think in the mid-January, and we'll now change it and update it to actually create the SITS geospatial specification, in which we will specify how to store the data itself, the context about the data, and some basic rendering information about the geodata. And the second thing is the common technical specification for the GIS system, where we actually describe some standards that can help us define structure, rendering, and behavior of it. Now, due to our short time in this field, we started with some basics. There are still a lot of things that we need to develop. We need to actually test this in the real world to see if our theory, if our approach is correct. There are standards that we are approaching and using for that. However, we still need to see if it is applicable. That is why the specification itself will be more of a guideline than a fixed specification. And this SITS GIS guidelines will come out, I believe, in the end of March. And we will be very glad if you would look at it and see if you have any comments, if you would like to change some things, or you have some questions that are not specific enough for that. And if you would like to join or participate, please give us, send us an email, or just contact the DLM forum for our information, and we will give it back to you. Now, if we go to the SITS GIS guidelines, what is actually going on there? Basically, in this SITS GIS guideline, we focused on identifying ISO standards and OGC, which stands for OpenGIS Consortium Standards, which is a standard body for geospatial standards. And we saw that basically the context can be well defined by using metadata for web services that are defined in the new ISO standard 19115-1. The structure of GIS objects. So if we go back to the building permit story, there is a standard OWS context which were presented by a gentleman from the UK, and on the previous Geoforum. You can still see the I think the presentation is available on YouTube. And then we have the rendering definitions that can be defined using also, this is a typo, it's a OWS, not OWA context. There's an SLD style layer description standards, and there's a web mapping service description standard, which also defined the rendering. And of course, the behavior can be stored in a way if we take the CRS transformations, the transformations of coordinate systems in the OWS context. And of course, we can use the UML as a standard to define the workflows. On the other hand, there's also a possibility to do this using just code and descriptions and so on. Because I think that we always will have a dilemma of how much effort do we want to put into preserving a GIS system by transcribing everything into a machine-readable form, or just having a blunt description, a video, an interview, or a text file describing something, because it might not be as accessible as a digital machine-readable form, but it will still be available. It will not be lost. So this is our approach on how to actually use technical guidelines for preservation of GIS. But what can be done aside from that? Before the specifications are ready, we need to think about our information system as being preservation ready. So is our system preservation ready? First, we need to check if our system is very well documented. Do we have standardized metadata definitions of our data, of our information products, of our web services that are based on INSPIRE or on ISO 19115 standard? Then, do we have a standardized specification of coordinate reference systems and transformations that are taking place, or is this being defined sporadically as people actually use it with different names for the same coordinate system and so on? Do we have a documented structure and organization of geospatial records so that we know exactly how the data is structured, why is it structured in such a way, so that we can reproduce this in a different GIS later on? And this is where we should actually strive to ask our GIS providers to document our system before they deliver it to us. A very important element for digital preservation of geospatial record is the clear temporal definition and organization of the geospatial records. So do we know how to access the state of the database in, let's say, May 13th of 2012 or not? How difficult is it for us to do that? And if we don't have a time series definition or time series approach strategy for storing our data, then we might have difficulty preserving our system. Then we have the rendering documentation, which sometimes is defined as a GIS project that helps us create a web service or an application service. And how is this rendering defined? Can we reproduce it using the old data if we want it again? And of course, do we have the provenance and the authenticity of the geospatial record sources? So if we have a product, do we know how the source data was created, where the source data comes from? Do we have the source data preserved or defined in a way so that we don't have any issues there? there is no possibility of changing the data and so on. So these are some good checkpoints to check in our GIS system before we start actually preserving it. And this is something that all the geodata producers and GIS providers can do now. And this is where the archives can help educate the producers if they don't have their systems preservation ready. And now I would like to all invite you to the second Geospatial Digital Records Preservation Conference. The idea was to have it in Ljubljana, but due to the COVID situation, we decided to go and to create an online event. We will come out with the announcement shortly. We're now talking with the EC to actually set up the page and publish it. And definitely DLM Forum will inform you of this event when it's available. So this is all from me for this presentation. So this is where we go to the Q&A section, and I would really like to ask you if you have any questions regarding this. Please write them into a chat, and then Christy, are there already any questions?
Not at the moment.
Okay.
But perhaps if someone wants to ask directly, it's also possible. I mean, you can talk and ask your question.
I have a question.
Yes.
I work for Rijkswaterstaat. It's for the Ministry of Infrastructure and Water Management in the Netherlands. And I was wondering, how did you decide to have the information product as the object of preservation? Because for us, that's just one distribution of a system or multiple data sources. So I was wondering how you decided to have the information product as the object of preservation.
Well, this decision was based on the approach of creating the OIS system. So in the OIS, what we usually do is we ask ourselves what the user wants in the end. So what do people want to get in a DIP? And usually they want to have the access to the data that is produced from the current systems. So if you want to have an official statement that this is your land or something, you go to the archive to get the old record created again. So this is how I understand it. And sometimes in the GIS, this is not simply created by using the data itself. Just as you saw with the building permit, you actually, if you want to reproduce it, I mean, you can create all the building permits there are and store them, but this in the digital world, this actually would create infinite amounts of elements possible.
And
So,
how do you see it? Because in our situation, the information product is publicly available, but there are some data which are not publicly available. So the information project is actually a certain view on the whole data we use.
yes.
So,
Yes, I agree that sometimes some data is not available to the public, and also you need to create a decision which data elements you will store. Sometimes you will not store everything. We agree here.
Yeah.
But if we want to preserve an end product, we need to know how it was made and not delete some of the data just because we could then omit this. And also now when we have the open data directive from the European Commission, which is intended to actually support the data-driven economy, this data is now more and more usable. And I mean, this is the direction we're going into. These are the guidelines. What you do in the end is actually your decision based on your policies and your approach. But this was how we planned to do this.
Yeah. Okay, thank you.
Welcome. Any other questions?
The chat box is empty.
Okay. Then I guess everything is clear, or nothing is clear, or but okay. If you still have questions, please email me. I will be glad to answer and also debate the questions with you, because we need inputs from the community who actually uses GIS system and who actually executes the preservation of the systems, not to only be a theoretical approach with the specification. So I think that we are now very close to the start of the second presentation. So if, I mean, I can answer one more question if there is someone, but otherwise we would go to the next speaker. Okay.